Okay, so let's start. Sorry for this technical inconvenience. Thank you very much for inviting us to this conference. Very sorry for not to be able to attend physically, because I think that it would be much better. But due to busy end of the year, I wasn't able to travel. I will share today with you some use cases that have been developed at Airbus by the different set of competencies. First, short introduction of our context, then challenges that we are facing, our link to the standard, and some examples. I will not deep dive technically into the example, but it's just to give you a flavor of what we are doing and how we are using FMI. And then I will share you some feedbacks and some questions that we have. What is the context? Context of Airbus is that we have a complex product to develop. Unfortunately, or fortunately, we are not alone. We have to deal with a lot of partners and suppliers. You have the number. It's around 80% of our models that are coming from outside. So our task is really to take into account all these models in order to perform our task. What we want to do, as Christophe presented just before, we would like to deploy system engineering within Airbus. And then how not to deploy FMI, because FMI, an open standard like FMI, may give access to a new solution and technologies that could be incorporated in our domain. What are the main challenges that we are facing? Integration, as you can understand, and also interoperability, because we have to make work model together. So this challenge is a very big one for us. What are our objectives for Airbus and the ecosystem? Ecosystem is partners, suppliers, and also a team between the different centers of competence within Airbus. What we want to do is to optimize tool and model integration, to share simulation infrastructure development effort, to be able to reuse and to share best practice and tools. Then it can enable and share new business solution for simulation task. And what we would like also is that with the help of this, the usage of the standard, we will increase our collaboration spirit. FMI and Airbus. As you can see, FMI and Airbus is not a new story. In fact, we are following the standard till 2011. And on 2016, we really did a real assessment on the FMI 2.0. At that time, we decided to go and use FMI as much as we can when it is possible to use FMI. So from 2016 to today, FMI has been spread across all our divisions. We have also the release of FMI 3.0, which is very important to us because it will bring a lot of new features that we want to deal with. That's why we decided to go to the advisory board committee in order to be closer to the FMI ecosystem and to the different people that are using this standard to share knowledge, and also to be close also to our suppliers. Example of usage of FMI, one of our center competence, power plant competence, which is linked to engine. In this example, it is at the top left side of the V cycle. It's at the early design phase. In fact, in this case, we are receiving models coming from suppliers, and we have to integrate it within our already existing simulation framework. What we did is to evaluate the encapsulation by the FMI standard of models coming from different tools. It was, let's say, it was a good use case because we managed to make the model run with no big problem. We have the opportunity to test either the model exchange mode or the co-simulation mode. So notable for us, it was let's say a simple case. Supplier is well-defined, tools are well-defined, and our simulation infrastructure is also well-defined. Our aircraft cabin center of competence wanted to go more deeper into the exploration of the FMI usage. As you can see on the right, top right part of this slide, they wanted to explore all the V cycle. They wanted to be able to reuse the behavior model from the early design phase to the integration phase. They managed to do it using FMI as a black box and also as white box, because the most inconvenient of black box FMU is that you are receiving something that you don't know. Without a supplier specification, it's really impossible to debug it. So we are spending a lot of time to solve the issue. Then what we explored is to have a white box FMU. And with this white box FMU, we were able to use this FMU all along the V cycle, from the model in the loop part to the software in the loop part, and even in the hardware in the loop part. We tested the usage of the FMU in the vector test, in the vector card. This was a very good example. What they tried is to use FMI, but they need to build by their own the simulation infrastructure. So it is as the prototype. It is now at the prototype stage. Now we want to go to the COC systems. The COC systems is the COC that is in charge of integration of the different models in the real systems. Today we have the AP 2633 internal standard. With this standard, we have ensuring that all models are communicating in the right way within our simulation infrastructure. But we see in FMI the opportunity to ease and to extend nature of models that can be integrated into our simulation platform. As AP 2633 is part of our DNA, then we are not able to change it. what we decided, what systems COC decided, is to integrate, to build a wrapper around the FMI and to use this encapsulated FMI in our current simulation platform. Today, it is running for FMI 2.0, and now we are investigating to use FMI 3.0 in this simulation platform. For our space system divisions, it's the same way of working, as we have a strong constraint regarding standards to be used in the space system environment. It is ECSS SMP. So we are not able to avoid this the use of the standard. That's why it has been decided to also encapsulate, to build a wrapper around the FMI and to wrap it, to make it compliant to the ECSS standard, and for us to be able to run it on our simulation platform. Last example is the example that made us discuss with some of you. It was the usage of AI in order to produce usable models, and that's why we are discussing with Meli and Stephanie's team in order to be able to encapsulate ONNX model within FMU, and in order to make it runnable on our simulation platform. These are the different examples that are developed by our Center of Competence. Now it's getting more and more used. I only took a very small sample of example, but in fact, the standard is really well spread within our different COC. Now, what we want is to go to a large scale, as it was said by Christophe before. System engineering is now is not nice to have; it's mandatory, and we need to provide all possible enablers to this adoption. We have some feedbacks from our teams. FMI is a complex standard, difficult to integrate and deploy. They refer to a special editor in which, for at each version of the editor, you have a certain way to produce FMU, and we are not sure that it is compatible with the current simulation framework. Debugging FMU coming from suppliers is difficult. How can I be sure regarding the IP protection? And also we have some, I will not list all the feedbacks, but what is important to us is that, okay, we are able to encapsulate models within FMI. We are able to integrate them, but now are we able to prove that our results are credible? So we have the simulation credibility topic also on the plate. And of course, we have to deal with the complexity of the assembly of the models that we want to have. We are very limited in terms of assembly, and it's due to calculation performance, and then we are looking for a solution for that. As conclusion, what I may say is that what we see is that, okay, we want to go and use functional homocode interface for all our new next-gen programs for all of our divisions. But what we need to care is the contract between the FMU provider and the FMU user. It also we need also to take care about being very careful regarding the new technology. I really like the document provided by Andreas Hugenans and Thorsten Blockwitz. FMI is great, but not magic. Before FMI, you have some boxes, then you can order them. But as you can see, you can also have catastrophic results. And some of our team faced this issue. But what we need is really, as I said, to be clear about the contract between the FMU provider and the FMU user. This is the end of my presentation. Thank you for your Thank you for attending. Do you have any question?
I was expecting
yeah. Du coup, tu peux...
Can you hear me?
Yes.
Okay.
Any question?
Yes. First of all, thank you. Fantastic and spot on. And I think I would like to have 1 or 2 hours to discuss with both of you. Maybe we can make that happen later on. But I now reduce myself to only one question. If you say contracts, and that certainly there is a legal aspect and commercial aspect and that kind of things that also play into life cycle management of models coming from others. But what about behavioral contracts for models? Do you use something like, for instance, assume guarantee contracts or something, so that you specify what you expect as behavior from not only the physical component that you buy in, but also from its virtual counterpart from the model?
Yeah, by contract, in fact, it's let's say something. It's something like an agreement. I mean that we are working with Black Box FMU, for instance. At the beginning, we received Black Box FMU. The contract is just to please build the FMU, and we will integrate it. There's no contract. There were no contract. Now, when spending a lot of time debugging this Black Box FMU, in fact, what we decided with the supplier is to say that, okay, you want to protect the IP of the model, but from our side, we need also to be efficient in the integration. That's why we need to have access to some variables. That's why instead of having a big black box FMU, we managed to negotiate a gray box in which we can investigate, let's say, some behavior of the parameters that are blocking us. Does it answer to your question?
It does. Thank you very much.
Welcome. Mm-hmm. Regarding the model exchange, for us it's a convenient way to use models. But I'm aware that when you are doing model exchange, then you can, in fact, do introspection into the model itself. So it's not a black box anymore. And why we are using cost simulation is because we are ensuring that IP protection is guaranteed. But unfortunately, when we are doing co-simulation, we are facing major performance issues. It took for us, when we are dealing with co-simulation, we have, I think, 24 hours of model running. And at the beginning, it was unacceptable. That's why we looked for machine learning in order to spend the 20 hours one time and then reuse it with the help of a surrogate model. But today, we are still asking ourselves about using model exchange or co-simulation. We are using co-simulation when we don't have a choice. And if I'm not wrong, OSP is based on mainly on co-simulation. And this is a question that I have: is it pure co-simulation that you are calling co-simulation? Mm.
Thank you.
Thank you. And let's exchange if needed. We will share the presentation as requested. And don't hesitate to come to us if you have any questions. We'll be pleased to answer. Thank you very much. Have a nice day. Bye-bye.